Hello everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. And students, I know till now you have done a lot. Like today is day 2 and already naming reactions has been uploaded. And now we are going to do important reagents and distinguished tests. So today is basically day 2 and I know that you have enjoyed all your videos and yes, a lot of hard work I'm doing for only for you guys, right? And I know just few days are left for your exams. So let's start without wasting any time. Let's start the class. So today we are going to do basically important reagents and distinguished tests. This is going to help you a lot in your revision and recalling what are the important things that you must do, right? So if you talk about chlorinating agents, so PCl3, PBr3, these are halogenating agents that produce halogen, and out of this the one very famous one is PCl5, that is a chlorinating agent. If you have alcohol or you have acid, here OH will be replaced, and if you have ester, here OR will be replaced by the Cl, any of the halogenating agent if you have, right? Okay, now next is if you have RX, that is alkyl halide, with KNO3, because KNO3 is a very important question that why this happens, because here you have ionic bond and here also you have ionic bond. So here basically what will happen due to the ionic bond, it will actually K, this will be ONO, this is negative, and that is why oxygen is also available for the bond. So here answer will be RONO will be the answer. In the case of Ag, here it will form a covalent bond with oxygen, and that is the reason this oxygen is not free. So bond will be done with the help of this nitrogen, and hence the answer is RNO2. Very important, right? Next is here you have K positive, Cl negative. So this C is free for the bond, so it will be RCN as the answer. And here you have Ag and C, right? Here they are covalently bonded to each other, right? When they are covalently bonded, this carbon is not free, this nitrogen is free, and that is the reason answer will be RNC, right? So answer is going to be RNC is the correct answer here. RNC is the correct answer here. So here you have cyanide, isocyanide, R with oxygen bond and nitro with nitrogen bond, right? So these are reason is because of covalent bond and ionic bond. They ask you to state the reason for the following, right? Okay. Next part is alcoholic KOH. So alcoholic KOH is a kind of reagent that is used for dehydrohalogenation. So you have any halogen, let's say you have C, and here you have X, and here you have H. So what will happen here? Halogen will be eliminated and here hydrogen will be eliminated and double bond will be shifted here. But the question is, ma'am, beta. This is called alpha and this is called the beta position. Ma'am, which hydrogen will be eliminated? Whether we will choose this hydrogen and here double bond will be shifted, or we will choose this hydrogen and here double bond will be shifted. So answer is you will have that answer which has more number of alpha hydrogen. That means according to SETZEF product, that means more alkyl substituted will be your correct answer. More alkyl substituted, where on the double bond you have more alkyl chains, that will be the correct answer there. Okay. Now next is aqueous KOH. Now in aqueous KOH, if you have let's say R, Cl or X here, let's say we have Cl, you add aqueous KOH, now things will be very different. This will replace Cl with OH. This thing will take place. That means what we want to say, in alcoholic you have different approach, in aqueous you have completely different reaction, right? Okay, now let's talk about alkane, where you have which do not react with KMNO4. Alkane do not react, but there is tertiary alkane that reacts with KMNO4 and this hydrogen is replaced by OH. Again, a very important reaction. Okay, this only happens in case of tertiary alkane. Okay, next is dilute KMNO4. This is actually Beer's oxidation, or you can say Beer's reagent. This is Beer's reagent. Now here we know that this is actually dilute KMnO4 is of pink color. Right. So here what will happen, by syn addition, this double bond will break and you will have OH here and you will have OH here, and hence you will have your answer there. Okay. And hence you will have your answer there. Got it? Done? Okay. And here syn addition will occur. Now next is mild oxidizing agents and strong oxidizing agents. So now I will distribute it into mild, strong and copper, right? So let's say you have mild oxidizing agents like PCC, PDC, CrO3, that is chromium oxide. In that case, 1 degree will be converted to aldehyde and 2 degree will be converted to ketone and 3 degree will be converted to which thing? Very good everybody. 3 degree will be converted to no conversion will be there. Yes, this is for mild, right? If you have strong, what will happen? If you have strong oxidizing agent, this will be further converted to carboxylic acid, right? Carboxylic acid. Here ketone only will stay and here you will have no reaction. Okay, with copper at 300 degrees Celsius, what you will have? Here you will have, this will be converted to carboxylic acid, this will be converted to aldehyde. This will behave as mild, right? Then here you will have ketone. An important part is alkene, 3 degree alcohol, which was not reacting before, is now going to give you alkene. Is now going to give you alkene as the correct answer here. Okay, got it everybody? Next is ozonolysis. Now in ozonolysis, the simple funda is, if you have zinc, water or Me2S, that is oxidative ozonolysis. In case of alkene, what will happen? Let's say you have R here, you have R here. Let's say you have H here and H here. So now, or let's say here also you have H. Now what you need to do? In reductive, break the pi bond, attach double bond O, double bond O. So it is double bond O. This is R and this is H only. Here also it is double bond O. This is 1H and here also 1H. That is reductive ozonolysis. In oxidative ozonolysis, this further, all the hydrogens that are connected to carbonyl carbon are replaced by OH. So answer will be C. Here you have R, here you will have OH. This will be double bond O, and here it will be C. This is H, this is OH. This will be OH and this will be double bond O. That is nothing but H2CO3, right? So H2CO3 is actually very unstable. So it is already dissociated to water and carbon dioxide. Water and carbon dioxide. Okay, everybody, do let me know if that is clear to all of you or not, right? Okay, now we have allylic bromination or chlorination. Now, in this case, what you have here, let's say allylic or benzylic, basically if you have N-bromosuccinimide, Br2H mu, or you have Cl2H mu, what will happen in these cases? If you have allylic means double bond, next to double bond you have a carbon, that is the allylic carbon. This hydrogen here will be, this position is the allylic position. This is allylic position. So this hydrogen will be substituted by which thing? By chlorine. That is called allylic substitution. And same here, if you have benzylic means you have benzene, and this carbon is actually called as not this carbon. Yes, actually connected to this carbon is the benzylic position. This carbon is the benzylic position. Now hydrogen connected to this carbon here, right? That will be substituted by Cl. That is benzylic. Okay, that is called as benzylic. Now we have dehydrating agents. Dehydrating agents means just like dehydrohalogenation, you will do the same thing, right? In this case, they are going to take away water, all these reagents. Here you will have OH, here you will have H. OH negative will be eliminated, H will be eliminated, double bond will shift here, and that is your dehydrating agent. Again, the answer will be according to Sedzeff rule. More alkyl substituted will be the correct answer here. Okay. Next, guys, we have NaHSO3. In case of NaHSO3, now this is basically a distinguished test because I have mixed important reagents and distinguished test here, right? So here you have this test where aldehyde and methyl ketone will give this test and they will give white crystals here. That's it. That's only what you need to know about this, right? Okay, or you can just answer it like this. This is C double bond O. Actually, what will happen? This is NaHSO3, right? This is positive, this is negative. So what will happen? This negative is going to attack here. These electrons are going to jump here. This will be O, this will be Na, this will be OSO2 H, right? Now here they will be interchanged. Here you will have H and here you will have Na. This will be actually white crystals. They will have white crystals. Okay, but in this board examinations, they don't ask you this much. You should only know that they will give you white crystals. That's it, right? Next is Tollen's test, very, very important test. Now, in this case, firstly, you should know this Tollen's test is given by aldehyde, formic acid. It is given by both aromatic and aliphatic aldehyde. Alpha hydroxy ketone, that means on alpha position you have hydroxy. Hemiacetal means the carbon which has R, OH, OR and 1H, that is hemiacetal. So all of them gives Tollen's test, right? And what is exactly Tollen's test? Now Tollen's test is basically what? It is Ag positive ion, right? That is from silver ammonia solution, right? And here if you have aldehyde or that aldehyde or whatsoever among these you have, that will be converted to RCO negative, and here silver mirror will be formed here. Silver mirror will be formed in this case. You should know which of the following shows Tollen's test, right? Okay. Next part is I would like to tell you about, wait a minute. If I am writing Tollen's test here, then it's better to write, okay? So yes, I think that I'll delete only, right? That I'll delete only because it is here also. So I'll firstly show you Tollen's test here because as I have started the test, so now I'll continue with the distinguished test only, right? So as I told you, all of these will show positive Tollen's test, shows positive Tollen's test, and the reaction is RCH3, a silver ammonical solution you have, which get converted to Ag. This is the overall reaction that you have, right? Now, next is Fehling test. In Fehling test, you have Fehling A and Fehling B solution, right? Fehling A solution is what, everybody? Fehling A solution is CuSO4, right? And what about Fehling B solution? Alkaline solution of sodium potassium tartrate. That is also called as Rochelle salt. And here CuSO4 will react with NaOH to give you COH twice, which reacts with sodium, potassium, and this whole is tartric acid, so tartrate. And that will be the answer, which will be deep blue colored complex. And we just represented by Cu2 positive, the deep blue colored complex. This will be converted to reddish brown precipitate if there is presence of aldehyde, and which will give this test? Only the aliphatic aldehydes plus all these things. You can say hemiacetal plus you can say alpha hydroxy ketone, right? All these will give this test, right? And here also you should remember Tollen's test is also given by terminal alkynes, okay? They don't give silver mirror, they give white precipitate with Ag positive. So that's why we say that it gives positive test. Next is Benedict test. See, the difference in Fehling and Benedict test is that Fehling test is actually, you just need to make it instantaneously, but Benedict you can store also, right? So here it is aqueous CuSO4, everything is same, but here you use citric acid. So citrate is used here, everything else is same. Cu2 positive is getting converted to CuO2, that is reddish brown precipitate, results everything is same, right? Just instead of tartrate you have citrate here, right? Okay, next we have coupling reaction. Let's talk about that. Coupling reaction is actually azo-dye test. So what will happen here? In the disonium chloride, HCl will be eliminated and here you will have a dye which will tell you that here phenol is present and here what you will have a orange color dye. In case of phenol, O, so it is orange, right? Okay. So now here what you have, this is N2, right? And this is benzene and this is going to be NH2. That is a yellow color dye. Now here you remove HCl here and this will give you, this is benzene and this will give you, this is N2, this is on para position. From the para position I will attach this and this is actually reaction with 2-nephthol or beta-nephthol. And this gives you scarlet red. Which dye is scarlet red dye? Okay, scarlet red color dye. So they can ask you the name of the dyes here, right? What color of dye they can give you, right? Okay. Next is 2,4-DNP test to detect the carbonyl carbon. Now simply 2,4-DNP test means, this also I'll show you later on, right? I'm just marking a cross here. I'll tell you why I'm marking a cross here, okay? Because I'll tell you this after some time, okay? So Hinsberg test. Hinsberg test is, this is the Hinsberg reagent, that is S double bond O Cl. This is the Hinsberg reagent. Now let's see how it reacts. So with the primary, if you have primary amine, this is to distinguish primary, secondary and tertiary amines. For the primary amines, HCl will be eliminated and here because of this hydrogen on the nitrogen that is still there in the product, it will be soluble in the alkali, right? Now reaction with secondary, this HCl will be eliminated and hence you will have the answer here. Here you don't have any hydrogen, so that will be insoluble in alkali. So in the secondary, the product will be insoluble in the alkali, and in tertiary it does not give any reaction. Okay, yes. Next is Carbylamine test, where this is a test only for primary amines. Here primary amines in the presence of chloroform and KOH will give you isocyanide that has a very foul smell, very bad smell test. So secondary and tertiary do not give the test, only primary amines will give this test. Only the primary, whether it's aromatic or aliphatic, primary amines will give the test. Okay, yes. Aliphatic or aromatic both will give, right? Next is Iodoform test. Very important test. In Iodoform test, what you have, there is some compound that gives this test. You have NaOH2 or you have NaOI, right? Now here what will happen, this bond will break. Here you will have the attachment of ONA and here this will be converted to CHX3. Because here iodoform, iodine we are using, so that will be CHI3. Because CHI3 is actually of yellow color, so this is maximum use. This is the most famous haloform test, right? Now the question is, ma'am, which will show this test? So first thing is one which has C double bond O CH3. Whether it's aldehyde or ketone, it will always show this test. And we know that there is only acetaldehyde which has this kind of, only acetaldehyde has C double bond O CH3. So I will not ask you to cram it. I'll just tell you, just remember this particular thing should be there. And then there should be CH3COH. That means what? Just reduce this. This will be, I'll just write it like this. CH3, C double bond O should be there, or CH3, this is COH and this is H. This should be there, right? This should be there. Now here understand one thing, that this should be there, plus in ethanol we check this. These kind of secondary alcohol plus ethanol, they will give this test. Okay, these kind of secondary alcohol, and out of primary only ethanol will give the test. So that is very important, which of the following shows iodoform test. Okay, now and yes, one more thing, it does not, yes, I think it is not written over here, but it does not react with the double bond. Double bond will stay as it is. For example, I have some compound where it is like this. So this double bond will stay as it is. Okay, this double bond will not be reacted with the iodoform. Okay, yes. Next is ferric chloride test, that is given by phenol. So in the phenol, neutral FeCl3 solution is there. Development of violet, purple or blue green color depending upon the nature of phenol will be there. It is only for phenol and some enols. So for you it is phenols only, and if enol is present. But you will consider it for phenols, right? Then next is sodium bicarbonate test, that gives you detection of carboxylic acid. Reagents are NaHCO3 that easily reacts with carboxylic acid. Now here what exactly happens, carboxylic acid, that too even if it is aliphatic or aromatic, they give this test and they release CO2 here, right? And the release of CO2, liberation of CO2 will detect whether carboxylic acid was present. It is not given by phenols, nor alcohols, nor aldehyde and ketones, right? Okay, yes. Then guys, next is, I think this is the last distinguished test, and after that we'll do some important reactions, right? Now this Lucas test is actually given by, does not give Lucas test. Now Lucas test, if you see, it is 1 degree alcohol, 2 degree and 3 degree. Just like Hinsberg reagent is for 1 degree, 2 degree, 3 degree amine. This is for 1 degree, 2 degree, 3 degree alcohols, right? So this is in concentrated HCl and anhydrous ZnCl2 is the reagent here. Phenol will not give this test, and 1 degree will react. Firstly, I will start with 3 degree. 3 degree will react very fast, gives white turbidity immediately. 2 degree alcohol will give turbidity after 5 minutes, and 1 degree after heating, prolonged heating, and it is going to give you white turbidity after 30, 40, 50 minutes, and that to prolonged heating. So very poor towards this reaction. Okay, got it? Got it, guys? Now let's see some important reactions here, right? We were here. Now these reactions are somewhere hidden in your book, right? So you usually sometimes ignore these reactions. This is a very quick recap for you to understand that these things are important for you, right? So ether and concentrated HI, ROR, concentrated HI, what will happen? Either this bond will break or this bond will break. The question is, O should go with this R or O should go with this R. How you will solve this? Answer is, if both alkyls are primary, then this follows SN2 mechanism. Then in that case, iodine will go to that part which has less steric hindrance. But if one of them is tertiary, then this reaction is SN1. Then iodine is going to that part which will be more stable carbocation. That means iodine will be formed by 3 degree carbocation. Okay, got it. Iodine is a selfish person. He always thinks about himself, right? If it is SN2, he will say, I want less steric hindrance. If it is SN1, he will say, I want more stable carbocation. Very selfish person iodine is. Okay. यहाँ पे you can write Iodine is selfish person, very selfish. Okay. Now LiLH4. LiLH4 reacts with carboxylic acid, ester, acid, chloride, convert all of them to alcohol. It also converts amide to, this will be break and this will give you CH2NH2, and it also converts cyanide to amine. Okay, and this one also to amine, right? Then it does not react with CH2 double bond CH2. But if you have like we are saying, if in a acidic system, if in a aldehydic system you have C double bond, then it will not react. Okay, but if it is in a cinnamonic system, that is phenyl CH double bond, then this also will be reduced, this also will be reduced. That's a very important question of your NCERT, right? Then NaBH4 has a different equation only. NaBH4 does not react with acid or amide or ester. It only reacts with aldehyde, ketone, acyl chloride or imines, right? Okay, all of them to alcohol, right? As you can see over here, right? Okay, understood? Yes. So this should be one bond here, not two. Okay, yes. Now DIBAL is diisobutyl aluminium hydride that reacts with acyl chloride or ester or cyanide or acid. It converts all of them into aldehyde. Okay, next is Grignard reagent. See, Grignard reagent shows two kind of reactions, very important. First is Grignard reagent finds any proton source. Proton source means any source which gives you proton. It can be H positive from alcohol, it can be from alkynes, it can be from acid. Anywhere it gets proton source, it will be converted to alkenes. Okay, it will be converted to alkenes. Second is, if you have carbonyl, first kind of reaction is it with the proton source, other kind of reaction is with the carbonyl group. This is negative, this is positive. It always attacks any carbonyl. I am not only talking about carbonyl group, I am talking about anything. For example, here what will happen, this will react here, this will go here and it will give you C, and this will be O negative, MgX, and this will be R. Now MgX will be converted to OH. Depending upon whether here you have alkyl or H, you will have 1 degree, 2 degree, 3 degree alcohols. Now the same reaction is given if you have carbon dioxide, right? This is RMgX. Okay. So here what will happen, negative, positive, again this will attack, this will go here, carbon with double bond O, and here this O negative will be converted to OH later on when you add acid, like when you hydrolyze this, and here it will be R. So this will be acid. So Grignard reagent always behaves like this. R part is the negative part which will attack on the less electron density position. Okay? Yes. Now next is hemiacetal acetal, where what you have, in hemiacetal you have aldehyde. Aldehyde, when it is reacted with alcohol, it is going to give you hemiacetal, that is carbon with one OH, one OR, one R and one H. Okay. Then when you add one more alcohol, then this part is further going to get converted to OR, that is nothing but acetal, right? Now when ketone do the same thing, when ketone does the same thing, you have the formation of carbon with two alkyl just like here, and this one part is converted to OH here, right? And one OR will be attached here. Okay, that is hemiketal. You add one more group of alcohol here, then this part is also converted to OR, that is ketal. Okay, so basically what is happening, same thing. This lone pairs are attacking here, then the electrons are shifting here, right? So you can just directly write it as here as well, ROH, lone pairs will be attacked here, electrons will shift here, carbon OH, This will be R, this will be R, and here OR will be attached. Okay, so directly also you can do that. Okay. Now, we can see that when you have an like aldehyde or ketone and you react it with ethylene glycol, this whole part water is released, and here you have this carbon is connected to one oxygen and one oxygen here and here, and rest of it remains the same. That is cyclic ketal is formed in this case. Okay. Okay, now the next part is cyanohydrin, that says if you have KCN or HCN, this negative part here, basically what is happening, you have HCN, you add any base here, it will produce a nucleophile with CN negative, and that is going to attack here. This electron is going to jump here, it will become R, this is O negative, and this is CN. After hydration, this will be converted to H. That is nothing but this is cyanohydrin, which is again a very famous reaction. Okay. Now next, I know you are not able to see this. I know that you'll be like, ma'am, oh my god, I'm not able to see this. Don't worry, this I gave you for notes only, right? So now I don't know who is texting me right now. Oh my god, so many messages. No, company only is texting me, guys. Notifications are coming. Random notifications. So here you have any carbonyl compound. If you reacted with NH2 and here there is some Z, Z can be anything, then water will be released from here, and this carbon with double bond N, double bond then N then Z, this will be formed here, right? That means the answer will be this. Now this part can be anything, this part can be anything, R or HH, anything will be added here, and this Z also can be different things. Accordingly, this thing will be, this is actually amine, this is Schiff's base, oxime, hydrazine, phenyl hydrazone, 2,4-DNP, semicarbazone. All these answers are made, that I will give you the PDF, right? And this is also your NCERT snip only. Based on the value of Z, you will have different answers here, different needs. This is very important. Okay, don't forget to do this, right? Okay, now I will show you that test that I talked about, that is 2,4-DNP. Now actually same thing is happening. You have a carbonyl. 2,4-DNP is when on benzene on second and fourth position you have NO2, and this is actually in hydrazine. You replace one hydrogen with benzene, and second and fourth position you have NO2, right? So here what will happen, water will be eliminated, so you will have C double bond N, NH, then benzene, then NO2. That is orange or yellow precipitate will be formed, and this shows that you have the presence of this carbonyl group here. Okay, so that is the test of carbonyl group. It may be aldehyde or ketone, both of them. Now let's see the rest of the questions, guys. Only 3-4 things are left, very important. Now if you see Cl2 anhydrous Cl3 or FeCl3, FeCl2, that is what, this is all. Now you will ask, ma'am, one more thing, ma'am, we are also blank on that thing. See, if you have any benzene, if you have any group which is attached to benzene, which has lone pair, then this will always show plus M effect, always ortho para directing will be formed. If you have any group which is connected to pi bond with some more electronegative element, it is always going to show minus M, that is always meta directing. And also if you have any group which has positive charge, then also it is going to show you minus M effect, and that is meta directing. Okay, and plus M are always activating, minus M are always deactivating. But there is one exception here, exception I will write here. Exception is halogens. Halogens show plus M effect, they are ortho para directing, but what will happen? But their minus I effect is dominating as compared to plus M, so they are deactivating and they are plus M, right? So just in case they ask you this, you should know all of this, right? Okay, so now whenever an electrophile is attacking, if you have anything like this, it will show you ortho-para directing, ortho and para position. Like for example, phenol, aniline, they will give you ortho-para products. Benzaldehyde, benzoic acid, they will give you meta product. Okay, but how electrophile is generated? Let's see that. Electrophile will be, if you have Cl2 and hydrous Cl3, that will produce halogenating agents, that is X positive. This will produce you NO2 positive. This will produce alkylation, that means R positive. If you have RCOCl, it will produce RCO positive as an electrophile. Here you can use RCOCl or anhydride also you can use. If you have concentrated HNO3 or oleum, then it is going to give you SO3H as the attachment. Okay. Now, based on the same concept what we have, there are some important things here. See, if I talk about bromination, right? If I talk about, this is phenol. In case of phenol, the important part is Br2CS2 will give you ortho and para product. Mono products are formed differently. Ortho product is different, para product is different. But if we give bromine water, then tri-substituted product is formed, and here it has white precipitates. This one also has white precipitates. This is also a test of test of this phenol only, right? But in case of aniline, see which one is more reactive, aniline or phenol? Aniline is more reactive. Why? Because aniline is not clever. Because nitrogen has less electronegativity as compared to oxygen, so nitrogen is not so clever, it will directly give the lone pair, so it is more donating. So these positions are more reactive, so here always tri-substituted product will be formed. But if you are saying, ma'am, I want to have mono-substituted, you need to do acetylation, that is you need to convert one hydrogen over here to C double bond O CH3. So this will be replaced by C double bond O CH3. Here what will happen? Now this nitrogen will be so busy in this conjugation that this will not have time to give electrons to this benzene, and that is why its reactivity will decrease, and hence only para product is formed. And after that, nitrogen COC3 will be like, bye bye, I am going from your life. It is the same situation. A beautiful girl will enter into your life and you will be like, oh my god, what a life I have. And same applies to girls. A handsome boy will come into your life and you will say, oh my god, this is like everything I need in my life. This is like, yes, I can ruin my board examination for this person. You will ruin it. Earlier you were doing tri-substitution, now you are doing mono-substitution. But that person will go out of your life. That person will say tata, bye bye. Same thing will happen here. Okay. See, nitration, what will happen? Nitration, we were thinking that aniline, I only told you, if on benzene you have lone pair, then this will give you plus M, that is ortho-para. But here you have meta product, that to 47%. The question is why? The answer is that because here, due to the acidic conditions of H2SO4 and HNO3, this is converted to anilinium ion, that is this. And this anilinium ion is actually meta-directing, because on benzene you have a group that is positive charge, and that is the reason it gives you 47% of meta product. Ma'am, I don't want to have meta product. First, they will ask you this question, why this happens, okay? Even tomorrow, I will give you some PYQs of organic. You will see these questions being there, right? Now, aniline reacts with CH3CO2. Now, if I want to have para, first I will do acetylation, so that these nitrogen are not like I want to accept proton from acid. I want to accept because I am an acid. Now here what is happening? This is a base, this is an acid. It accepts protons from this acid. That's why it gets converted to anilinium ion. Now we make this lone pair busy. We say you can't accept proton because you are not that of a good base. So it cannot accept. So that's why it is now busy with this Kanya, right? This girl, it is busy. Now what will happen? NO2 will be attached to para position, simple nitration will take place, and after that this girl will say tata bye bye because you have failed in your board exam. You were not studying when Diksha ma'am was teaching. I was studying. I just distracted you. You're like, oh my god, I wish I could have studied when Diksha ma'am was teaching such amazing things, right? So, yeah. Done. Acha. Now, last one is N2Cl. Most of the reactions I have done in already in naming reactions. Sandmeyer's, Getterman, Bal-Schiemann reaction, all I have done in naming reaction. One was left here, and that is if you have H3PO2 or EPOH or HCOH, directly it will be converted to benzene. And from phenol, how you convert it to benzene? From phenol, you add zinc dust. Then it will be converted to benzene. And here to here, how you will go? This is aniline, right? You add HNO2, that is NaNO2 and HCl at 0 to 5 degrees Celsius. It will show diazotization, right? Okay, so let me see if we have done all the questions. Yes. So guys, it's 41 minutes and we have completed all the important reagents along with the distinguished test in this video. So these are power pack sessions for you, and this power pack series is actually going to help you a lot in your exam, right? So guys, tomorrow I'll be taking important organic conversion, top 30 organic conversions I will take, right? And after that, I will take top 30 previous year questions of organic to make you pro in your organic. So see you all guys, see you all in tomorrow's session, and do write it down in the comment section how you liked these sessions. Till then, bye-bye, take care.